Hi everyone, this is our overview and practice lecture on scientific notation. So scientific notation is used when the numbers are too big or too small for a calculator. So if you have a calculator handy on you, you can try it and just type random numbers on there, but at a certain point it'll stop, right? And you can't input any more numbers, or sometimes, certain calculators it changes your numbers instead, whatever you're inputting. But in our case, there are going to be times where the numbers are going to be super big or super small, and we want to be able to calculate using those numbers using our calculator. So we would change them into scientific notation so that we can fit them in there. So there's an example down there, and I don't even know how many place values that is, but that's how many atoms are in the Hope diamond. And then they changed it from the big number to the small number right here with the exponent to shorten it, so that if you input that in your calculator, it should fit just fine. And you would read that 4.6 times 10 to the 23rd, right, or 23rd power is how you would do that. So how do we convert something into scientific notation? So this would be the slide to really focus on if you want like what the steps are. So you're moving a decimal point until there is one digit to the left of that decimal point. If your exponent is going up, then your decimal point moves to the left. If your exponent goes down, that means your decimal point moves to the right, or vice versa. So they give you an example down here. They give you this number, 156,000, and you want to put that into scientific notation. So you just move your decimal 5 places to the left. So what that means is you see that decimal right there, you're going to take it and you go 1, 2, 3, 4, 5, and it's going to move right here. That's where we get the 1.56, and then all of these zeros pretty much just go away and are represented by the exponent right there. So you move your decimal 5 places over, and that is how that looks like. And then if you go backwards, right, same thing, you take your decimal, you go 1, 2, 3, 4, 5, 6, right, and that's why this one is a -6. So it's always going to be 1 point something, or 9 point something. It's never going to be like 15.6, right, or 53. It's going to be one place value point something else. So we'll do practice right now. So this was from the earlier example. How do I get this big number down to that, right? So what you're going to do is you're going to take your decimal. In this case, hopefully you can notice that there's no decimal given to you. These commas right here are just, there to help separate your numbers. So those are not decimals. You're not going to use that. So when there's no decimal given to you, your decimal is going to be at the very, very end of the number, right there. Because technically that means like 0.0, right? If we're trying to be more, specific and exact, but in this case we're fine either way. But your decimal starts there, and then you're gonna just count how many steps it takes for you to get over here, right? Because that's what we have right here, 4.6. So we're gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So there you go, right? 23 jumps, so your exponent is going to be raised to the 23rd power. So it's going to be 4.6 times 10 to the 23rd. That's how you do that. Two things to remember. If it's a positive exponent, that means that your number is quite big, right? So these are bigger numbers if your exponent is positive. Right? If your exponent is negative, that's what we're going to look at right now, this one right here. So if your exponent is negative, your number is going to be small. So if you take a look at this number up here, right, you can see all those tiny zeros behind the decimal point. So same idea. You're going to move your decimal point and you're going to make it go over here, right, to the end of the number. So you're going to do your jumps. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. right? And again, if we were being exact, that would technically be 2.0, right? But we don't really need that extra zero at the end, so it's just going to be 2 times 10 to the negative 23rd atoms of carbon. So if it's negative, your number is going to be a decimal. If it's a positive exponent, your number is going to be a big number, a whole number. Okay, so here's an example. So what I would suggest is just pause it here for now, try it on your own, and then once you're ready, just play the video again and see if you get the right answer. So pause it right here. And hopefully you've tried it. So if you're back, right, let's go ahead and try this out. So I'm going to just rewrite it here just so we have enough space. So that's the given number, and it says that it wants us to jump 10 spaces, right? So we take our decimal that was given to us and we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So your exponent now moves right here. Fill in your slots. When I was younger, they were called baskets, and you can call them whatever you want. So just to make sure that we put them in the right place values, I'm just gonna, divide them by the commas. Oops, sorry, that one's wrong. That one's supposed to be right there. So technically our new answer is this. Whoops. Oh, now I lost my place. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right, so you should have 7 zeros, and this would be your final answer. So when you're doing your jumps, these guys right here do not go away like the zeros do, but they do show up. So again, it's not going to be like 2,654. It's going to be 2 point and then all of the numbers behind it, and then they do count with the jumps, just like I showed you. And that will be your final answer. Okay, let's try it backwards. So same numbers, just we're going backwards because it's negative. So I'm going to write it again, but I'm going to scoot over here a little bit because we're going to the left this time, right? So you're going to take your decimal, you're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decimal right here. And you fill in your slots. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 additional zeros. Right, so these guys right here, this time don't count for place values because we're going to the left. And this would be your final answer. So you should have 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 extra zeros in front of your 2. That would be your final answer. Okay, here are some more practice. So again, what I would do is I would pause the video and try it out on your own, and then play it again when you're ready to see the answer. So take a few minutes to answer those. And then when you're ready, here are the answers. You should have gotten 7 times 10 squared, or to the second power. We got 6.51 times 10 to the 8th. We got 1.25 times 10 to the 6th. 3.01 times 10 to the 8th. And then 1.0334 times 10 to the 6th. So just something to pay attention to with these two right here. Hopefully you added these numbers, right? So there is a 0 in between those, but if there's still, non-zero numbers there, you still need to include it. So hopefully you got the right answers for the two last ones there. Okay, now let's go backwards. So again, pause and try it out yourself first before you continue playing the video and check out the answers. Okay, now I assume that you have practiced on your own, so let's take a look at the answers here. So here are answers. So you should have 7 extra zeros on that first one. Here's the second one. 4, 2, 0. Then this one, 1, 2, 3, 4, 5, 6, 7 extra zeros. And then this one, 6, 7, 8, 9 extra zeros on this one. Okay, and that's it. That's going back and forth. So, putting them in the calculator, I'll show you guys how to do that later on, but being able to recognize them and being able to move between the two is important. Okay, so of course, now that we know how to switch them, now we need to figure out how can we add and subtract with these numbers, because there are some rules that are slightly different. So here's the first one. So if we're adding and subtracting with scientific notation, the exponents, if the exponents are the same, then you just add the coefficients. So coefficients are these numbers right here in front of your times 10 to the whatever power. Right, so if this example that was given to you, they're both raised to the second power. So all you're going to do is you're going to take the 7.35, add it to the 2.43, and then it'll show up as 9.78 times 10 to the second power. Right, obviously in a calculator, that's a lot easier to do, but again, there are certain things that you can do without a calculator and you should be okay. So that one's super easy. So then what happens if they are not the same? So if they are not the same, then you must convert the values to the one with the highest exponent. Right? So this is if they are not the same exponent. So here's an example. These are all different values of joules. And hopefully you can notice that they're all raised to different powers. So just like the last slide said, you're going to change the other ones so that they are raised to the highest power available, which in this case is 18. So here they are, right? So if we compare, these are the same. These are the same because they're on the 18th power already. The next one, whoops, spoiler alert there. The next one, see how they move their decimal point 1 over, so instead of it being 3.89, it's 0.389. Right, so that when you go and change it to the 18th power, then they will be the same value, right? So you're not changing the value at all, you're just changing the exponents to reflect that, right? Same thing with this next one right here. Instead of 5.44, we have 0.544. And again, if you write that out, it should be the same number, right? Nothing should change except for the exponent. And then this one, they had to move their decimal points 2 more over, right? So that would have been 1, 2. That's why it's 0.078, right? And then now that all the exponents are the same, you're just going to add this downward, and you should get something like that. Right? So it takes an extra step if they're all not the same exponent, but still pretty straightforward, I think. So it's always the highest power available, power or exponent. Okay, next one, how do we multiply and divide with scientific notation? So these ones, they come in 2 steps, right? So here's multiplication. The first one is you're going to multiply the coefficients and then add the exponents. And if you're dividing, then you're going to divide the exponents, then subtract the exponent of the divisor from the exponent of the dividend, right? These are words talking about which one you're dividing, by, or which one you're dividing the other way. So let's take a look at a few examples. So here's the first example, right? It's multiplication. So just like the steps on the next slide said, it said first you're multiplying the coefficient. I'm just gonna abbreviate, and then you're going to add exponents. Right, so if you multiply 3 times 2, that should be 6. Right, these are the coefficients again. 3 times 2 is 6, and then you're going to add 3 and 2 together on the exponent. So your answer should be 6 times 10 to the 5th. Right, that should be your final answer. So multiply and then add. Okay, here's another one with a negative kind of squished in there. So same thing. First step is multiply coefficient and then add exponents. Right, so you're going to add or sorry, multiply 9 times 3 is 27, times 10 to the, and then you're going to add these, right? So when you're adding, a positive and a negative, then it's just like you're subtracting, so it's just going to be to the positive fourth power, right? Just like that. So if you need to